All right, let's try part C of exercise 25, which reads, for the function g in part B, find g prime of 1 and use it to show that the summation from n equals 1 to infinity of n over n plus 1 factorial is equal to 1. And what we're going to do in this situation is find the derivative of g as a function and substitute in 1, and compare that with the derivative of g, the power series, evaluated at 1. And hopefully when we put those two things together, we will get the expression that we're looking for. So we're going to start by finding g prime of the function. So that's going to be taking d by dx of the original function, which is e to the x minus 1 over x. And I'm going to have to use the quotient rule, which says that I take the denominator times the derivative of the numerator, which is going to be e to the x, minus the numerator, which is e to the x minus 1, times the derivative of the denominator, which is 1 because it's just x, divided by the denominator squared. And we can simplify this a little bit here. So we're going to have x e to the x minus e to the x plus 1 all over x squared. And then the whole point of this is to find g prime of 1. And so when I substitute in x equals 1, I'm going to get e minus e plus 1 all over 1, and that's going to give me 1. All right, so now we want to look at the power series representation. So let's just remember that g of x is equal to 1 plus x over 2 factorial plus x squared over 3 factorial plus dot 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 plus a general term that's x to the n over n plus 1 factorial. And then of course this goes out to infinity. And if I want to find g prime of x, I'm just going to take the derivative here. So I'm going to get 0 plus a half plus 2x over 3 factorial plus dot 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 plus n times x to the n minus 1 over n plus 1 factorial, and that's just going to go on to infinity. And then once again, what I want to do is evaluate g prime at 1. And really, I can write this as a summation before I do that. So I'm going to have n equals 1 to infinity of n times x to the n minus 1 all over n plus 1 factorial. So when I substitute in x equals 1, I'm still going to have my summation here from n equals 1 to infinity, and I'm going to have n times 1 to the n minus 1 divided by n plus 1 factorial, and that's going to give me the summation from n equals 1 to infinity of n over n plus 1 factorial. And because of what I proved up here, that's going to be equal to 1, and that is the expression that we were supposed to show.